Hey, hello friends, welcome back to the channel. This is Aili Bhattacharya, your stats buddy, and today we are going to start with our first chapter, Random Variables from Probability Distribution, and this is our second semester. All right, so let us start with our first slide. See, what are we going to study today? First, let me discuss that. Yes, we are going to study about random variables. You heard it correct. Random variables are a tough topic, but you will understand it very clearly. Okay, we will understand today what they are, how they work, and how to represent them using something called the probability mass function. So let us get started. Let's start with an example. Suppose we flip two coins. The possible outcomes are what? Written as the omega, heads, 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 tails, heads, and tails. Now let us define a random variable x as the number of heads we get. So for omega, tt, what are the values of x? 2, 1, 1, and 0. Alright, so x takes values 0, 1, or 2 depending on the outcome. This is a discrete random variable because it only takes specific countable values. Alright, now how do we describe the probabilities for each value of x? That is where the probability mass function or PMF comes in. For x equals to 0, which is no heads, probability is 1 by 4. We already know that. And for x equals to 1, for one head, it is 1 by 2, which is 2 by 4 is 1 by 2. And for x equals to 2, for two heads, it is 1 by 4. Now, there is an important distinction. See here, discrete random variable and continuous random variable. What is discrete random variables? Discrete random variables take specific separate values like counting heads, and for continuous random variables can take any value within a range like height, time, temperature. All right. PMF is usually used for discrete random variable. And what is PDF? PDF is probability density function which is used for continuous random variable. Today we are only focusing on discrete and the PMF. All right. Now you will see the general equation or how we write PMF. Okay. But the general formula. Px equals to Px equals to xi if x equals to x1, x2 and goes on, and 0 if otherwise. So the PMF gives the probability at exact points and 0 everywhere else. Now we will do a recap. Okay, a random variable maps outcomes to numbers. This is the first point. Number two, discrete ones take countable values. Countable values. Okay. Number three, the PMF tells you the probability for each value. And fourth is for our coin example where probability of x equals to 0 is equals to 1 by 4, and for probability x equals to 1, the it will be 1 by 2, and for probability x equals to 2, which is 2 heads, is equals to 1 by 4. And that is the basics of random variables and PMFs. If you find this video helpful, give this video a thumbs up, subscribe for more math and stats content, and hit the bell to stay updated. Leave your questions in the comments below, or you can directly DM me in my Insta. And yes, thanks for watching. Stay tuned. Bye bye.